Hey, what's up everyone? Welcome to a new episode of Tester Tech. Today we're continuing with the Linux Basics series. If you're new to the channel, welcome. My name is Eric and in this beginner guide I try to teach you the basics of using Linux. This is episode 5 and we're going to look into processes. So how to inspect processes, how to stop them, and also look into services at the end of this video. So, if you haven't subscribed already, please consider doing so, helps me out a lot with this channel. And if you're new to the series, check out the playlist, I have a couple of other episodes out there. Without further ado, let's dig into the video. Hey, what's up everyone? Welcome to a new episode of Tester Tech. And today we're going to look at processes. So the first way to look at processes is to use the ps command. So ps will not show you that much if you just run ps, but let's check the manual. As always, man ps report a snapshot on the current processes running on the system. Scroll down a little bit and you can see the examples here. So ps-e or ef and all these variants. And you can also use the BSD syntax AXU and all that stuff, and also print it as a tree. So let's first just do ps-ef, right? So you will have like a process showing every process, not only my processes, but also the root processes, and you can see the table here. So the first is the user ID and then a process ID, and I actually don't know what these are, but the process time and also the command. So the whole command string that's being used to start the process. And this is cool and all, but I guess you would want to single out a certain process. Let's say, let's start it off with Java application. Let's go to the downloads folder. And we have Jenkins here, and we can start Jenkins with java-jar jenkins.war. And it will start up Jenkins. So I already configured this. And let's give it some time. So see, Jenkins is fully up and running. If you want to stop this Jenkins process from this terminal, you can do that, of course, by pressing Ctrl-C. If I can press Ctrl-C, I stopped the whole Jenkins process. So as you can see, my cursor is responding again. If you run it again, hit enter, give it some time. So it will lock this terminal emulator. So this terminal, it will be busy with handling the process. So it will only respond to keyboard interrupts. So we're in downloads, and if we hit java-jar Jenkins war, and you can see here. So now it's running there, and let's open up a new tab, and let's do ps-ef grep Jenkins. So here you see this is the process 27795, and it's doing running using Java, and then this is the argument here, and it's my own user. So that makes sense. If you look here, it's fully up and running. So let's check. Let's go localhost 8080. Jenkins is indeed running. So just to show it's not nonsense. So here you have like Jenkins up and running, right? I'll move that out of the way. If you hit Ctrl-Z, then it stops and it puts it in the background. So if you hit refresh here, basically will not do anything now. It's like stopped. And if you want to activate again, FG, it pulls it up again. And let's reload now. As you can see, it just starts responding again. So it's like pausing a process and giving it back to the terminal again. So you see my cursor, I cannot do anything now. The only thing I can do, of course, is hit Control C or Control Z, Z again, C or Z. And if we want to stop it, Control C, and then I kill the process. So shutting down using Jetty. It will not be running now again. So let's do a quick check here. As you can see, only the grep command itself that I do here is being reported. Okay, let's start it up again. So this is starting. And let's grab it again. Here you can see 28126. And this is indeed running. And if we want to just kill it, kill, and you can do this pit. So 28126, 28126. Enter, check back here, and it's stopped, and that's indeed the case. So let's grab it again, as you can see here, and let's show you in the browser. Go to the dashboard. So it's not responding, so it has indeed stopped Jenkins process. And now if you run it again, and let's grab it. So last time it was 28126, and let's grab it again. And you can 28294. It's a different process. That makes sense. Every time it's a new process ID, so this is dynamic. Just keep that in mind, that every time you cannot do the same number over and over again. If you kill it, you need to grab it first and then kill it in that way. So let's move this one here. So we have it here. Make it a little bit smaller. So as you can see here, it's better way to see it. So let's say you want to kill all Java processes because it's flooding and you want to stop everything. So let's first check how many there are. Just one. And this is grep, right? So this is Java. So you can do kill all Java. And here it stopped the process. Grab it again. And you can do kill all, but you can also do just, if you want to just stop one, so pkill will also work. Pkill Java will also work. Let's show you. So to start it again, pkill Java. Maybe it's a little bit too soon, but yeah, indeed, it does indeed kill it anyways. So that's PS for you, and you can dive deeper, of course, with going into the manual, and you can have like various other ways to present it with more table or thread it, and yeah, but that's a little bit more detail, I would say. Just have a look at the manual. So if we're talking about background and stuff like that, if we want to start a process like say here in this terminal and not make it hang up and keep it here, then we can use the no hub command. No hang up basically. So if we have the no hub on Java jar Jenkins war, and we type the ampersand behind it, hit enter, then it does indeed put it here, and this is the process D. So 30943. Let's check it again. PS EF grep Jenkins here. So the Jenkins is here 30943. So now we can do everything we want in this terminal. If we want to bring it back up, FG, here we have it again, right? And that's similar to the Control Z, but the difference is that this just keeps running. This keeps running. So now let's stop it. Control C. So let's show you that again. And what you can also do is redirect the output. And that's also very handy. So let's say you want to redirect the output to a file, Jenkins, for example, Jenkins out, txt. So here, indoor input and redirecting standard error, standard out. So you can do stuff here, but it doesn't actually make sense, of course. Let's grab it again. Jenkins, it's there. Let's go to browser. So this is responding. And let's say you want to stop it. Control C. And Jenkins out. So you have all the file, all the information stored here. And then you can also combine that, of course. Let's do ampersand here. Ampersand. All right. So yeah, now you have it at your disposal again. All right. So every time a process is started, it gives a file in the proc directory, the proc. So ls proc. So here there are processes started for every process basically. So let's do that. Let's start at Java here again. Give it some time. So let's do ps ef grab Jenkins again. So 28681. This is now existing. This process ID. But if you want to dive a little bit deeper, it actually is a directory. So let's say you have that and then the 28681. You see there's a couple of files in there. Here it's exe is Java. Status, you can see these metadata, for example. Let's do command line, and let's cat that out. So here you can Java dash jar Jenkins var. So it's there. It's a little difficult to read. The format, spaces are gone, but yeah, you can see all these files here. So every time it's created, there's a process created. So cwd, the current working directories, downloads. You can see more metadata on that process. It's pretty cool, right? The only way to remove it is to kill that process. So let's hit Control C here. So it's stopped. There's no such file directory. Now let's say you have you want to monitor. So on Windows, if you're coming from Windows, you have like the task manager, of course. And here in Linux we have top. And there are a couple of other variants, I will get to that. And top will show you a list of processes, and it's sorted now by CPU. So the highest amount of CPU is shown here. So the process that uses the most CPU, let's word it like that. And then if you start this Java process, it will start showing here. Here you see 400%. You might be wondering, of course, that's each core can go to 100%, right? So now that's done. And if you want to see more, and you can also see the PID here, but this will update each time, right? So depending on the CPU. But if you have a long running process here, and it's a high CPU, then you will be able to see it. If you want to see more, then type question mark, and then you can use these commands to see a little bit more. And you can also kill here if you have it selected, kill, renice, and All the good stuff is in here. So if you type M, for example, you see the memory here as well. So top is installed on most Unix-like operating systems, at least Linux, it's there already. Alternatively, htop can also be used. So as color and it looks a little bit nicer. You have more statistics overall. Here are all the CPU cores. It's 16 ones or threads. I don't know exactly. Memory. So this is similar to what we saw before. And let's say you have the Java. Let's say you want to search here. Let's make it. It was covered by the screen key. It's F3. You can also click on it. Say search here. Jenkins. Enter. Jenkins. Here you have it. So it's now selected, right? And what you can do is kill it. F9. Let's kill it. Enter. So done. So it killed Jenkins from this. So you can also do that. So no Jenkins is allowed anymore. So let's say you want to also kill Firefox. Kill all Firefox. Enter. So go back to htop. Should be no more Firefoxes left here. So these are ways to see processes. Quick summarization, you can look into the PS. So print a snapshot listing of the processes. You can go into the proc directory, proc/proc. And you can use top and htop as well. And now let's say you have like a service. And service is systemd. Or on many Linux operating systems, there's systemd. So I know there's a lot of controversy around systemd. I won't get into that. For me, as a Linux user, I think it's convenient to have systemd. It's service. So service is user admin service. So sudo service. So you see usage service. So all. Oops, status all. Sorry, status. Status all. And now you have all the system services. You have an overview of all these system services. And let's say, for example, Docker is an interesting one. So status. So now you have the status of Docker. As you can see, it's running. And let's you have the whole trace here as well, right? The whole yeah. If there's an error, you'll also see it here. And if you want to stop it, let's do stop. Give it some time. Let's go to status again. Here, inactive, dead. So it just stopped. So all right. And let's start it again. Start, you can start it again. Status, you see running. All right. And if you, the first time you have installed a service and you want to enable it on boot, then you should use systemctl. Sudo systemctl and give the command. Let's first take a step back. You can use systemctl as well to stop systemd service. Stop Docker. All right, let's do the status again. Here, Q to quit it. And let's say you have the systemctl and you can enable Docker. And that will create a symlink that it will start Docker on the boot. And now. And that will also enable it and then also start it. So let's go to the status again here. All right, so that's also systemctl real quick and systemd showed you that, how to start up systems. So how to start up services and how to enable them. I would say, as always, check the manuals if you're not sure about that whole thing. Oh, one thing. Yeah, so as always, these are files, right? So the system services are like configured in files, and sudo. So if you go to cd user lib systemd, and for example user, here, these are all files, so service files. So here you have user files and you have system files, and as you can see here, Docker is also one of these. So let's cat docker.service out. This is just if you have an application, and this is an ini file, the application will deploy this file here as well. And here you have the environment, and here you have the exec start, user bin dockerd runtime here. So basically what it should execute and how it should respond to your commands through systemd. So that's, I think, basically it for this episode. So if you missed anything, let me know, and see you the next one. Bye bye.